Welcome to today's presentation. The Knox Group has produced oil and gas in Holmes County for many decades. Much of the production is attributed to erosional highs or paleotopographic highs developed on the Knox Unconformity. In recent years, oil and gas production has been found along the updip truncations of the Beekmantown dolomite, Rosemont sandstone, and Copper Ridge dolomite against the Knox Unconformity. In this presentation, I will be playing the Rose Run Sandstone truncation edge to find prospective areas of structural stratigraphic traps against the Knox Unconformity. By using modern exploration software, it is possible to quickly recon and high-grade prospects, which previously was a tedious and time-consuming process. One disclaimer, this presentation is for demonstration purposes only. Please don't rely on it to go out there and lease the land, but feel free to try it on your own and develop your own prospects. We'll be focusing in Holmes County, Ohio, and looking at the truncation of the Rose Run Sandstone against the Knox Unconformity. Today's workflow will start with talking about loading vendor, particularly state data, into a GeoGraphix project, creating a regional map in Holmes County in GeoAtlas, visually mining data of the Knox Unconformity subcrop formations using conditional pies, identifying potential truncations of the Rose Run Sandstone, importing the regional Holmes County map into GVERSE Geomodeling, loading wells and formations into GVERSE Geomodeling, setting up the geomodel to model the Knox subcrop, apply the geomodeling tools to create the subcrop maps, querying the database for Rose Run producing wells, examining the subcrop with cross sections, defining the Rose Run play area, analyze the Rose Run reservoir characteristics, and high-grade the prospect area. Now for the demonstration. First, you need to load data. We acquired data from both vendor and from state and loaded it into the project. Then I subdivided the project into the Holmes County area of interest. Next, we'll look at GeoAtlas and bring up the regional map. From the regional map of Holmes County, we're going to do a little visual data mining by looking at conditional pies of the subcrop formations. So we're looking at the Copper Ridge, the Rose Run Sandstone, and the Beekmantown as wells with tops in those formations. So let's apply that. And by looking at the legend down here, you can see that the red pies are the Upper Copper Ridge, subcropping underneath the Knox Unconformity. The green pies are the Rose Run Sandstone, and the blue pies are the Beekmantown. So looking where the edge of the green pies are running through here, you get a good idea of where the subcrop would be here in Holmes County. We'll close GeoAtlas for now, and we'll jump over to geomodeling. First, let's load in the GeoAtlas map. This is the same map that I was showing in GeoAtlas. This loads in the same surfaces in the same order as we had in GeoAtlas. Plus, I'm showing a 2D line running through the Holmes area. Next, we're going to load wells into the project area. In the Load Wells dialog box, we have choices between loading all the wells into the interpretation or load wells on demand. If you have, say, 100,000 wells and maybe 2 dozen or more surfaces, you might want to use load on demand. But in this area, we're limited to maybe a few hundred wells, and we're just be looking at less than a dozen formations. So we're going to go ahead and load in all the wells in the interpretation. Next, we're going to look at the Geo Models Properties, where we're taking the currently active stratigraphic column, and we're going to load in the Knox, Beekmantown, Rose Run, Upper Copper Ridge, and Lower Copper Ridge surfaces. Now the surface types are important since we're going to be modeling the subcrop. The Knox is an unconformity, so in Strat Column Manager you have to be sure to mark the surface type as an unconformity surface type. The other surfaces we're going to be taking as formations that will be truncating against the Knox Unconformity. For our source of our surfaces, we're pulling all the wells data out of WellBase. For the constraints, we're going to be modeling upward from the lower Copper Ridge to the upper Copper Ridge, Rose Run, and Beekmantown, and do the conformance up against the Knox Unconformity. Next, let's look at the thickness maps. We're going to be looking at the thickness of the Rose Run isochore, which is sandwiched between the Knox and the upper Copper Ridge sandstone. Now I'm using the upper Copper Ridge sandstone as a top surface because it controls the extents of the subcrop. Now that we have the model configured, we're going to be turning on the Rose Run isochore and then apply the modeling tools of conformance and unconformity trimming and update the model. Next, let's put the well spots layer on top so we can see the distribution of the wells. I'm also going to turn on the Knox Unconformity structure. This shows the relationship of the Knox Unconformity structure against the truncation edge of the Rose Run sandstone. Let's zoom into this area as it is a producing Rose Run field. Here you can see the truncation edge of the Rose Run sandstone, plus this feature here, which is also a paleo high that we can see on this 2D line running through the southern part of the field. Here is the 2D line provided by Evans Geophysical running through the field. You can see the truncation edge of the Rose Run sandstone in this yellow stippled pattern here, in this 10:1 vertically exaggerated seismic section. You can also see there is potential in here for paleotopographic highs that are also productive in this field. Now let's zoom out to full extents. We want to place a buffered projected cross-section through the producing field. This will automatically buffer up wells within the buffer distance from the line of section of the cross-section. Again, you can see the truncation of the Rose Run sandstone plus some structural influences on this field. You can see the truncation edge both on the cross-section and on the map view. So that's our analogy. So let's take a look at this area here, which looks like it may be a potential trap with the Rose Run sandstone pinching out against the structure of the Knox Unconformity. So we're going to drag our line of section down over this area. And look at the cross section again. And here again you can see a potential truncation against the updip edge of the Knox Unconformity structure. We don't have to save this because we could always open it again. Next, we're going to activate a modeling region that will focus our efforts over here where we're seeing an analogy between the producing wells in this field up here and a potential trap play down here. So let's activate the Rose Run play modeling region. And this will load only the wells within the modeling region into the model, which will also focus you in on the area that you're looking at, but also it will create a much better performance because you're only looking at wells modeled in the extents of the modeling region. I'm going to examine next the distribution of the Rose Run producing wells. So we're going to pull up Query Builder. and I've already created a filter on it. Rose Run producing wells. And from this filter, I'm going to create a well-based layer to show the distribution of the Rose Run wells. Here are the Rose Run producing wells. Let's make sure we put those on top. So we can see the red squares are the Rose Run producing wells in this field, and there are some Rose Run producing wells down dip of the truncation edge that we're going to be playing here. So next, let's look at the petrophysics of the Rose Run sandstone. I'm going to open up GVERSE Petrophysics, and I've got a cross plot here in a picket format. So I'm going to open up the picket plot to calculate the required RW. Now I'm going to assume that these points on the well log, these data points, are wet or higher water saturations. So I'm going to move the 100% water saturation line right through here to calculate an updated RW, then apply it to the petrophysical model. Now you can see it updating now, so we have good water saturations from the Rose Run interval above the Copper Ridge to the Knox. So I'm going to cycle through the wells that actually have the Rose Run sandstone and take a look at the water saturations in those wells. And then make another well-based layer of wells with low water saturation or producing water saturations for the Rose Run sandstone. So returning back to the map. Here are the Rose Run SW wells. Again, put these at the top. And these are the blue diamonds here showing good reservoir quality, and a couple over here, of the Rose Run sandstone. So now we've got the play put together. I've got the Knox Unconformity structure. I see producing wells down dip. I see good reservoir in the Rose Run sandstone and a potential truncation edge that we can then go there and high grade this area to see if we're ready for land acquisition. So detailed cross-section work along with data QC can further define the viability and the geometry of the play. Petrophysical analysis can characterize the Rose Run sandstone reservoir quality. Production analysis of the Rose Run wells can help with the economics of the play. The main takeaway from this demonstration is that you do not have to spend weeks developing prospects. With modern tools available today, you can quickly recon the play area and high-grade areas to begin detailed work. I hope you enjoyed watching the play develop in my demo as much as I enjoyed creating it. I want to acknowledge the help in putting this presentation together. Cy Morgan with Franklin Gas and Oil provided the project data. Amy Lang with Foreman Energy coordinated the data acquisition and project transfer. Annette Evans of Evans Geophysical provided the 2D seismic line, and John French with LMPR provided technical assistance to the interpretation. The Ohio Geological Society for their encouragement and support, and the Ohio Division of Oil and Gas for providing the well data. Thank you for your attention and have a great day.